Okay, so I want to rant for a second about personal identification numbers.
Personal identification numbers.
Yeah, which is usually pronounced with numbers. Okay, so pins, not pin numbers.
High numbers.
Okay, so how long is a pin?
4 digits generally.
Okay, so my kind of thought here is guess somebody's pin, right? Or you lost your brain and you woke up and you had your debit card, but you don't remember the numbers. So how good are your chances of guessing this thing? Like, with no information, there are how many options for this?
10,000.
10,000. Right? There's 4 slots, 10 numbers available for each slot. Pins don't care about any restrictions at all, right? 0, 0, 0, 0. I get 4 in there.
Yeah.
That's an available pin number. Damn it. All right, so with no numbers, right, no information at all, there's 10,000 numbers. What if you knew 4 distinct numbers? So what if you knew their numbers? Yeah, so this happens in movies all the time where they spray some bullshit on the keypad and then they light it up and 4 of them light up. How many options are there for that?
24.
Why?
Because then you have 4 factorial.
Good, there's 4 factorial options, right? How much better is that in terms of guessing?
Oh my god.
Lots, right? Yeah.
If you had like repeating numbers in Nintendo, that make it harder or easier to guess? Like if 3 numbers lit up.
Excellent question. What if you knew 3 distinct numbers?
3 factorial plus 10.
No, things are weird now, right?
Like you assume one gets used twice. And then
So let me think about this. There's 4 slots, right?
There's 3 numbers.
And there's 3 numbers. No, this was my next thing anyway. So
Yeah.
don't
Shut up.
don't blame me. So if there were 3 numbers available, right, you know one of them gets used twice,
But you don't know which one.
but you don't know which
So
one.
there's still
so
5
it's
numbers. so
3
it's still
factorial times 12.
Yeah, let me think about this. I think it'd be something like there's 3 options for the first place, right? And then there's
Still 3 options.
there's still 3 options for the second
And then 2.
place. And then maybe 2 and 1?
But the doubling position can move to any of the 4.
Yeah, but this one doesn't seem like it has to go there. You guys see that? So, what do I need to do here?
Wouldn't there just be 2 factorial on the bottom because you have only 2 different places those 2 could be?
Oh, that's a good point. Let's see. So, what if we just played this game with 3s? Maybe I can figure this out. So let me just assume these were the 4 digits, right?
Yeah.
Okay, so this is one rearrangement. What else is there?
3, 3, 1, 2.
There's 3, 3, 1, 2. What else?
3, 1, 2, 3. 3, 2, 1, 3.
Okay.
3, 2, 1, 3.
There's 6 ways of arranging that.
And then 1,
You're going to get 3
3, 2,
factorial.
3.
Yeah. I think I'm going to get 3 factorial here. You guys see why? So what I'm trying to do is, these are my two repeated digits, right? And I'm trying to figure out how many spots are there for me to put them. Well, seems like there's, what? How many spots? How many different ways are there to arrange these two things in those 4 slots?
It's like you have 3 keys and then like other keypad.
Like you have 3 keys.
I don't know how to explain it well, other than just saying the multiplications you would do.
Yeah, so I think if we spent a little bit of time with this, we would find out that it's 4 factorial divided by 3 factorial, or 2 factorial, or something. How do I figure this out?
So you have 3 factorial.
Oh my god, this is how probability works. Sometimes you forget and then you have to sort it out.
3 factorial times 3 times the 4 positions that the 3 options would go in.
Say that again?
3 factorial for the ones you know are used once, and then the free option, the 4th option, has 3 choices that can go any of 4 places without affecting the 3 factorial you already have.
That doesn't feel like what I just wrote.
Well, what you just wrote was just simplified to 2, and we know there's more than 2 possibilities.
Oh, that's a good point. You guys see that? This can't be the right answer. Okay, good thought. Next thought.
4 factorial times 3 factorial? Because for every, in that example, you're not changing that first 3, you're only changing the second 3, and then once you're done with that, you're going to change the first 3. And keep the second 3 the same. But maybe the whole group of 2 3s moves as well.
Okay, so let's see. I think we missed an object, which was close to this. So I think we were close, but I think we missed one item, which is, so we had 4 factorial ways to arrange our things, kind of, to arrange 4 digits, right? We knew there were 4 digits, so we were thinking, okay, there's this many ways to just pick stuff, okay? Then I knew I was going to have to cut some of the possibilities out of there. You guys see that? Right? Because some of these are the same. So I thought maybe there are 3 factorial ways to put these kind of 2 things in amongst this other stuff. You guys see that? I think what I missed is what? I think there's one thing that adds kind of to possibilities in my head, which is that I got to pick one of those numbers. You guys see that? I got to pick which number was duplicated. So I had this is total number of ways to arrange things, right? And then I divided out by the fact that there were 2 that were the same, right? And so really I did kind of a choose type thing, but not quite a choose thing here. So I took the total number of ways to put 4 things down, and then I divided out by the idea that 2 of them are the same and the rearrangements of those 2 shouldn't matter. And then I'm multiplying by 3. Why am I multiplying by 3?
Because you have 3 choices for the one.
Yeah, because there's 3 choices for which number it is that's duplicated. You guys see that? You want the simple version? So the formula version is this. Cancel a 3.
4 factorial over 2 factorial.
Figure out that it's 4 factorial over 2 factorial.
But that's not how you figure it out.
Yeah, that's not how I figured it out, but I can remember. This is the digit arrangements divided out by the number of repetitions of one of the digits. You guys see that? Kind of, maybe. Okay. How about this? Should we do the other one? How about, what if we knew that there was, let's dumb this out and just make sure it works. What if we knew there was only one digit? What if we knew the one, you know, you spray this stuff on the keypad, right? And then you use the light thing and only one lights up.
There's only one digit in each spot, but we don't know which spot each one digit is in.
It's one digit four
You
times.
don't know.
Okay, so when you go like this, right, there's a keypad. And you spray this with some fancy luminol type gadget, right? And this one lights up. What's their pin?
5555.
They're dumb.
It's made of fives, right?
Which
Because they're dumb. So what happened there, right, is if I know the one distinct digit, right, I would say, okay, there's the total kind of possibilities that we're rocking, right, 4 factorial, and then we're dividing out by the number of repetitions factorial. So we know that one digit is repeated 4 times. So there is one possible way. Right, so one distinct digit makes one way. You guys see that? Is that what your pin is? 5. Did I guess it?
Yeah, totally.
So what was that explanation of why the bottom's 4 factorial again? Just so I can hear it.
So-
I didn't see what you wrote when you said.
Yeah, so normally we divide up by the number of different rearrangements, right? Then we also need to kind of multiply by this top, and so we cancel, right? So in the end here, what you end up with is the kind of usual distinct permutations, and then you divide out by the number of repetitions factorial. So in this case, I know that one digit is repeated 4 times. I have weirder problems if I have 2 digits light up, because I don't know if they're each repeated twice or if one of them's in there 3 times and the other one's in there 1 time. You guys see that? I skipped that case because it's funky. Cool? We could figure it out eventually, but it'd take us a second.